This is linear dynamic programming. So where we'll have only one state and should be able to use dynamic programming. Let's look at some of the examples. Climbing stairs. So given a set of states, given n in steps, with either one or two steps, find how many unique ways are possible to reach the top step. So steps enters. So so this is a recursion problem, and given only one state I, so how can I solve it? Either I can take the first step and two steps and solve I minus 2. So the base cases would be I equals to 0 and 1. For those two cases, there is a possibility of 1, and once someone reach these cases, that means you have a possibility there. Now we have initialized EP, set up both of the base cases. And for this range should be this solve and then return DP of minus. And to the next question. Minimum cost climbing stairs. So minimum cost climbing stairs. So this must be a problem as well. You given an integer array cost of I is cost by step in the case. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from the step index 0 or step index 1. With the minimum cost of each step of the floor. So either I can start at 0 or 1, and I can take 0. Either I can take 1 or 2 steps and have to reach top floor. We'll start at index 1, pay 15, climb 2 steps, reach the top. Total cost is 50. So return the minimum cost to reach the top of the floor. I can see that in this solve, must use recursion. What would be state? So I have only one. And what would be cost? Maybe 0, but you have to start. Then you have to start from 10 or 0. So the cost okay, you must have 2 at least, and then the answer is 5. We have only two values in the given something like this, and with the minimum, what would the cost to reach the top, the minimum of these two. And I have basically I can start this point and I could have come to this from 0th index, -2 index, or I could have come to this from -1 index. Right. So branching logic is at uh, I can calculate the cost as cost including that it would be this so more mm, 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 mm. I'm choosing right, then I have to choose the cost as well, right? And let's pick the delivery array. Let's pick the delivery array. Mm, Cost and then mhm, mm, mm, because you're starting from the you must consider the cost of the cost of one and I can which DPO and or before that and so on in I think I will do this. Yep, that's it. Mm-hmm. Strong. Other should be lucky number. House robber. House robber 2. What is house robber 2? House robber. The contact the police. Return the maximum amount of money you can rob tonight without altering the some numbers. Rob house. Three. Four. Here. Three. Four. Here. Not only one. We'll just go with that one. Otherwise, we will with maximum of deploy. Those two. But for the last, the next one, either you try to rob it or you skip it. But either you skip it or not should be based. Either you can drop it or it should be based on your max of I can rob it. I skip robbing it. This is when I skip robbing it. And this is when I rob it. Bit and I go for -2. What about house robber 2? Each house has a certain amount of money stashed. All the houses arranged in a circle. So they're not in circle and so when they're in circle, let's take concatenative version of numbers and then do it. Based on that, you can see whether it can be robbed. So it should be second. Adjacency, first and not working neighbors. So, these numbers cannot be dropped. Introduces this transform the transcontinental variant requiring separation into two independent scenarios that remain linear. Using -2 exclude the last one. Is 1 to minus the first. Each subprogram uses a standard recurrence. Either skip the current house or drop it. And the best way. Okay, let's prepare a different video if required for other linear type of deeper problems.